Yeah. In this tutorial, I'm gonna explain you the problem named median of two sorted arrays. So, given the two sorted arrays, you need to actually find the median. Median comes here in two ways. One is for even length array, one is for odd length arrays. But they actually gave you two arrays. You need to actually, usually in brute force approach, if you want to find the median, you need to actually merge them and then you can easily find the median. But that's actually brute force approach. And that's not what they intended us to actually code. It's actually categorized into hard problem and they won't go for that kind of easy stuff. They actually want they restricted in time complexity as they want within big of log n plus n. But if you consider the brute force approach, it actually takes you m plus n time because they actually given two arrays. You need to traverse on them and you need to merge them. So further only, it's actually m plus n time complexity. So, but they told you need to do that in the go of log m plus n. So if you go onto the Leetcode platform, you can clearly see that yeah, there is a description part. You don't need to bother about the code. You can see that later. Yeah. Given to sorted arrays num1 and num2 of size m and n respectively. So they are of different size respectively. Return the median of the two sorted arrays. So you need to return the median and the both given two arrays are actually solved. So they have also mentioned the time complexity that you need to complete is big of log n plus 10. And that's it. There's my piece of here. So if you consider the merging and finding the median, it's not gonna work because it's actually exceeds the time complexity that they mentioned. That is also and also this question is categorized into hard. So the reason they have mentioned into changes the category of difficult into hard because of this optimality in the code. Yeah, if you find the best approach, then you know why it's actually the hard to, and also the reason why they specified in the five something. So usually, if you actually find if we want to find the median, what would be for this one? Let's see. Then you'll get what is actually median for this question. So what is the length of these arrays? It's actually when you consider zero based indexing, it's being 11, and if you consider one based indexing, it's actually 12. This is half of the array, and this is half of the array. If you see in the two halves, there are six. So total 12 elements, and median is nothing but adding these two elements for adding those two elements if the array length is actually even and making it by 2 dividing it by 2 actually gives us a median. So this is for even length of the array, but we are not sure that we don't know whether the array is coming odd or even. So what would be the sum? It's actually 8. 8 by 2 is 4. But if you perform the brute force approach this way, it's going to be exceeding the time complexity and you're not interested to do this. So the final answer that we need is actually 4, and we'll do that in the optimal approach. And for us, what they actually specify. They want the time complexity reduced to the log m plus n. We go of log m plus n. So here log is coming into picture. Then it should strike in your mind that when logs come into picture and the given data is actually sorted, you can directly apply the binary search. So as a given that they actually mentioned that the given arrays must be sorted. So they are guaranteeing that those are sorted so we can use the binary search. That's clarified, right? So let's take array and apply binary search. And in this explanation, I'm gonna use the least size array. Means they give two arrays, right? What is the least size array? I'll pick that, and how I'm picking that one, I'll show you in the code. how we can able to pick the minimum size array, and it's actually a simple thing. It doesn't, it's barely two lines, I guess, to pick the smallest size array. And in this case, A is the smallest array, and here you go your A array, and here you go your B array. So what I'll do is I'll just apply the binary search on this one. I'll apply the binary search on the left is this one and right will be this one. And what will I get? Mid as mid equals to this one. So I'll store it in a variable. So assume that I equals to this one. What is this index? It's actually 1. So this is my I, and after doing that, it could be more, right? So what I'll do is just use the integer division in Python and get the value stored in the I. So after getting the index low plus I by 2, and I will store in the I. So this is perfect. So so you got a value, and now we need to perform j equals to wait a minute, I come see you once a minute. Yeah, small bit work and I completed that, and I'm back. This is the problem. Yeah, let's go the problem. What are these stuff? Yeah, this is the actual question, right? Yeah, I don't want this one. I don't want this. Oh, fuck, yeah. So we actually got a pointer I equals to 1. You know how I told you that, and we are getting this by using the binary search as left to right, and I do you got the mid as I equals to 1. And we want a variable, sorry, first I equals to 1. What is it actually telling? It's nothing but a pointer that can be that is being used as traversing on this array. But what about this one? You need to work on this one too, right? So we need another pointer that can actually traverse on this one. But how would you do that? Can we apply re again, apply the binary search again? No, we don't need to do actually that one, because that's not necessary. You can do with this value. If you cancel out some value with this value, then you know where you can put your pointer for partitioning stuff. So initially, what is your length of the merged array? If you take the both arrays into consideration, and what is the length? That would be 12. So what is the half of it? Half of the length of the merged array? It is being 6. So half as take two variables, total, which contains the total length of the merged array size. And you're not actually merging, but I'm just adding those length A plus length B, which is actually total equals to 12. What is the left? What is the what is the left or what? No, it's not left. It's actually half, right? Yeah, that's half. What is the value in the half? Half equals to 12 by 2 equals to 6. Half part is actually 6. So here you can't use total for this one, right? Because total is actually pointing to both the arrays well elements. How many elements are we pointing? So, but in if you consider half, you can actually use that half for this one, because usually you don't know the size of this is guaranteed by this one. You don't know that these arrays length is actually 6, but you can say that it's some part of the half, but it's not the total part. So you will take the half. Then what I'm trying to say is half minus I. What is half? Half is actually 6, and minus I is actually minus 1, and add it to a variable named j. So I is, now we got two pointers, I for traversing on this array and j for this array. And what is the value of j now? It's actually half minus 1 is actually 5, right? So we got 5. Now we got two pointers, and what is here? 0, 1, 2, 3, 4, 5. So we are pointing at 6. So J is pointing towards this element, and here I is pointing towards 3. So we actually have pointers, but those are not actually sufficient. Now we need to, we are checking for, can we, is the partition successful? So we need to check that case. Is the partition actually can be done or not? Is this with the bit values? Because you cannot guarantee that this is the right thing where we can do partition. There is a probability of having risk that we can't actually partition with mid value as system, because both the values are based on the mid value only, because they is actually dependent on the I, because based on I value it is minusing and taking the value. So it is actually dependent on the I, and I should be careful. And if the partitioning is not correct, then this won't be done. So j equals to half minus I means what is it? Is actually, so we do have both pointers, and now we need to check whether these can we act, is it partition actually correct. So to check that, you actually need some indexes. You need to compare this with this one. So you need four variables. First, let me write down, and then I'll explain you why we actually use it. So first one is AL, array of left. Next, A of right. Because we need to check is the partition correct or not. So to check that, we need these variables. So we can compare with both arrays one by one and check is the partition successful or not. And the last one is B right. So A left is actually pointing towards the eighth array's I minus 1 element, which is 2. So this is pointed by AL and this is pointed by AR. AR equals to A of I. And coming to B, it is same as, but array is changed. That's all. B of left is actually nothing but B left B, B left equals to B of J minus 1, which is actually this one. What? Yeah, this one. 0, 1, 2, 3, 4, 5. Wait a minute. Pointers are a bit confusing here, right? Let me erase this one. Yeah, we actually got J equals to half minus 1. Half is actually 6. 6 minus 1 equals to 5. So a pointer is 5. So 0, 1, 2, 3, 4, 5. And this is a value, and j minus 1 is actually 5. I'm actually confused. I'm pointing towards 4, that's not true. So we need to point, this is a BL. It means base array left element, and this is a BR, because B of R is nothing but B of J. So I'll just write here array of left equals to nothing but, within the braces I can write I minus 1, and this is nothing but array of I, and you see the B left is nothing but B of J minus 1, and B of right is nothing but B of J. So we got our pointers, and now we can actually point to these values, which are, I'm rounding up these values, you can see them. These are the values that I'm pointing currently, and I can work on these values and check whether these are partition actually successful, because partition is nothing but actually starting usually the array sort. So if you compare the side elements and the current elements with the other array elements, then you know whether the partitioning is actually helps or not. So in that way, you can, after checking that, you can, if Possible you can shrink the search space or else you can continue. If the partitioning is okay, you can continue your work what you want to do, or else you need to shrink your search space, binary search space. So currently we actually got a pointers that can actually help in pointing to these values, and we need to compare now. That is the pending part, and let's do that. First, we need to check array of left value is less than or equals to bth array of right. Is that true? Array of left, which is actually is 2 less than or equals to 6. Is that true? Yes, that is actually first condition is true. First conditions, other condition also there, and which is added with and because both conditions true, then only we will enter a condition and write the condition base. For first, I'm telling you the conditions what are there. Array of left value should be less than or equals to bth array of right element. Bth array of right element is so 2 less than or equals to 6. That's and along with that there is a subcondition. The other one is not subcondition, it's along with that one only, but an and gate is like and is there between them. So for that one, what is the condition is b left value should be less than or equals to array of right. What is b left equals to 5? Is 5 less than or equals to 3? Is that true? Never. 5 is never less than or equals to 3. So we can't execute the condition. We haven't satisfied this condition. So let me write the condition. If a of a and sorry why I'm writing if an value is less than or equal to pr and both conditions is be true, then only we will actually execute into the condition. If not true, we need to shrink the suspense. Either else or else if will be satisfied. So what is the other condition? As I told you, b left should be less than or equals to b right. B left value should be less than or equals to a right. Don't get confused this part. I'll make a line here. Yeah. And these are the two conditions. A single condition, and if this is true, we will enter the here what is there. But we don't know, we don't need to actually enter here because we have not actually satisfied the condition. So let's go to else if condition. What are the let's see what are the conditions. Not also fit else in Python. I'm going to show you the code also in the Python. And for else, what is the condition? The condition is nothing but inverting the conditional statement. Then it would be we don't need to mention those both conditions. We need to check here elif and else should be separately. So you need to use one condition only here. I'm using this one. And if this is the case, if array of left value is greater than b array of right, if array of left, which is 2, if 2 value is greater than br, is it true? Is 2 greater than 6? No, that's not true. Maybe here true, but not here. So wrong. I'm not marking such you. I'm marking this is true for this one, and this is false for this one, and this is false for this one, and the final statement that we have is else. So if nothing is a possibility, what is the condition? It means we actually done inverted this conditional statement for this one, and this should be come for else, and we don't need to mention because that is always going to be executed now because this is in being executed. So what is if we invert the conditional statement? If b left value is greater than or equals to a right, what is b? B left value is actually 5, I think. Yes, 5. 5 less than 6. Is that true? Sorry, 5 less than 3. Is that true? Never. 5 is not less than 3. So we need to actually shrink our search space. Not a search space. It's not matter of search space. Sorry, that's my bad. The word came from my end. That's not what you need to do. Never, no condition actually satisfied. Then this isn't the end. We actually come end to the while loop, then we need to iterate. And the while loop condition, it's not actually low less than or equals to high, left less than or equals to right. It's not like that. It's just while true. It will execute each and every single time if you don't actually return anything. And it will lead to your time limited exception, daily error, if you don't actually return something. So to return something, this should be actually first get what satisfied this condition. Either condition should be satisfied, and within that, if the internal condition is satisfied, then we have a constraint. Then only we will return true or will return the values. So up to now, we don't actually enter that part because with keeping the mid value as that position, we can't actually partition the array. So it's, that is actually fixed that we can't actually partition the array with the mid value as second. So we need to change the pointer. So we are going above, and while it's actually true because we specify true, it will execute unlimited times until it will return something. So so actually originally we are performing binary search on the array A, and now mid pointer will also be changed. And what is a mid pointer actually? What is the mid value? Mid value equals to this one, right? No, we don't need to actually go for the mid value because once we find that, yeah, um, yeah, well, it's actually done a blend. It's actually a blend. Usually, I is not pointing to one. It's actually pointing towards scale because for these uh, wait a minute. Do you actually understand all these conditions, right? Let's rerun that. Rerun that example. But these are the conditions that are standard. No need to you don't need to worry. And we'll just change the values and run it again. And this time it will work. I had done a mistake. And I'll show you what I have done. And these are all same and no with this. We need to erase this one because these are not the correct pointers that I need to traverse only. These are not the correct pointers that we need to traverse. Those are times blunder, a small mistake that actually leads to inefficiency. Yeah, no problem. That's not a case because we actually know what's actually happening. Statement. Yeah, that's the whole thing is because of the such skills that I use it as well. Yeah, let's continue. And from where you can get the questions from the website, right? So we're just reapplying the binary search and finding the low and high values, which is low equals to 0 and high equals to 4. 0 plus 4 by 2 is actually 2. And we are pointing at 0, 1, 2. This is where we are actually pointing. So, and I equals to 2. Remember, previously we got I equals to 1. That's the blunder. No problem with that. We actually understood the whole thing, how it's actually working, but just changing the pointer. So it's nothing. So we'll hit the condition somewhere here and there. It will be true and we will. So what is for B? Then B. B is nothing but as I told you that half minus I. Half equals to 6. 6 minus 6 equals to 4. So for B, the pointer we are using is J. And it will be 4. So J is pointing. What is J pointer? 0, 1, 2, 3, 4. So you are pointing a J at here. You are pointing a I at here. So just these pointers only change. Nothing change. The conditions would be same, no problem with that. Now, if you see that I minus 1, what is I minus 1? It's actually pointing towards this 3. Then A of left became 3. It means A of left value is actually 2. I will point this way, then it would be more clear. And A of j minus 1 is equal to this one. Sorry, A of, it's not A of j minus 1, it's actually B of j minus 1. Because B of j is this index, fifth element, and B of j minus 1 is fourth element. So we got our pointers, and this is done because we actually previously done that just listen digitally. And let's check the conditions what are to do and where we enter and what we will do in a sorry. If AL of AL value is less than or equal to BR, it means A of less. What is actually it is 3 less than B rate. B rate is actually 5. Is 3 less than 5? Yes, that's true. So this case is actually true. And what about this BL value is less than or equal to that. BL value is actually 4. 4 less than or equal to 11. Is that true? Yes, that's true. So both conditions are satisfied. Then this is saying that this condition is saying that bro, both conditions are true. It means the mid element as 2 we can actually partition. It means we are very close to our answer and we are satisfied with a position as mid equals to 2. So we'll enter here inside and we'll do work. What is the work? What we actually need to do? We need to actually find the median. So as I started told you that median comes into two ways. One is for even and one is for odd. So started initially we used two variables, total and half. We have used half effectively for calculating it, and it's time to use the total variable here to check whether the length is even or odd. So we'll do that if length value is actually even. That is what we actually use here. We will just write some conditions. If total mod 2 is actually just don't need this one also. You can just write this one for odd case. I'm writing for odd case, remember that. And this isn't the odd case one, but yeah, let me write this. I'll tell you. I'll write both conditions and I'll tell you which one is going to get you. If this is the case, which means if it is odd length, we'll do something, but that's not odd. So we don't enter the if condition and we'll directly do what is the other case. It's definitely going to be either it can be even or it can be odd. Other than that, it can't be any case. So if this is the case, we just return something here, but we don't need to bother about this one because we actually not executed it. We didn't actually satisfy this condition. This condition is false, and this true is for this both conditions, and this false is for this one. And we have will return something as here, and if that is actually satisfied with this condition, then you will directly return, or else you will return here because you don't need to even write the else. It's either you wish. For readability, you can write else or you can leave it, no problem, no one cares because if that's not, then this is going to be silly. So what actually we need to return in the given case, in the even case side, because this is for odd case and this is for even case. For the even case, you need these two values. These two values are nothing but, as I told you, started, we got the even length array, and these are the two values, and we need to add the what are the two values? Max of and these are two arrays, right? These are two, but what is our high point? You need to find the maximum at this element. You need to find the maximum. Find max, and then you need to find your minimum. Yeah. If you calculate this, what would be your answer? It's nothing but max of Here in the return statement directly what we are doing is return max of what are the pointers that we need to point here. It's actually J, I guess, max of J, J max of nums of J, wherever A of comma A of plus. I need to write in somewhere. Wait a minute. Let me erase this clean and I'll write here. I'll write here. Wait a moment. I have to stop this first. If currently we actually have the case else it being executed within the nested within the if condition we have if condition else and this else is being executed and what is this the condition is for here is max of is left comma is plus max of max of a rise a right comma a right explain how this actually no, no, don't want this one. This condition is being executed currently for this example, and what it actually means max of a of comma b of x. So do we need actually one more? Yeah, we need actually one more branches. Max of a left comma b left. What is a left? What is a left? Actually, a left equals to 3. B left equals to 4. So what is max? Max is actually 4. So 4. We got as 4 at here because we want the maximum elements from this 4 pointer. And we got as 4 max of a left b left. We got 4 and minimum of A right, B right. What is the minimum? 4 and here 5. What is the minimum from both? 4. So 4 plus 4. What is it? It's actually 8. 8 condition is not completed. 8 by 2. Not actually 2 conditions because it is given the real value. What is so we need to do the float division. So we actually get 4.0000 some stuff like that and completely valid and this is being returned finally. So even though the while condition is true, we'll just return because while loop only ends when something is written. So here something is this one this line where being executed and it is being written. But for what is for else condition? Not else. For what about the if condition? If it is odd, then we just actually need to return simply the element. Return directly that or what is that element we actually need to return? This max not, minimum not. The value is nothing but the left value. Sorry, it's not left, it's actually right of. Wait a moment, let me check you up on the last. This is there is nothing but this conditions or this is minimum of yeah, minimum of a of right, a of right. Yeah. Going to return the minimum of A of red, B of red, which is 4, 5, which is minimum 4. So here we'll return 4. That's here we'll return minimum of A of red, B of red, and this is the case for if condition. And what about this condition space? I told you that for elif condition, which is coming this way, these are all three cases, and within there here this comes for the if condition statements, and this we didn't talk about this one because we haven't figured these cases because the question lies that way, so we do it that way. And for elif condition, if a value is greater than br, it means if a, what is a? 3. If 3 value is greater than br, what is br? Br is actually 5. 3 greater than 5. If that is the case, then we actually need to string the space by towards left. So right, which is actually a variable of a binary a standard binary search variables, and we need to decrease it by I minus one, and for this one directly we can write that equals to I plus one, and this is the end. And let me show you the code, and this is the stuff. I'm going to show you code. Same thing, nothing is different. Yeah. So first we actually, as I told you that they will give you two arrays and we need to pick the smallest array. So I will put another two arrays and put the given arrays into the game, and then actually find the total length, half length, and pick the smallest one. This is actually one line, picking the smallest array as an A. So A is always going to be the smallest array because such area like this, the logic is like that, and let's just check for the binary search and while all the true it is going to exist all the time until it returns until it meets these two conditions. And these are the pointers that actually help us in pointing towards at the time of transitioning, and these are the safety measures that we actually use to not get into any kind of edge cases. So these actually helps these else conditions actually help in safely tracking those values. And if this is the case, if left value is less than equal to b of and this is going to be the return game, and these are the for shrinking the sectors. And that's if you run that, it will execute it and showing on that answer in the description. You can see here, it's also, yeah, that's it.